Tonight's kit build is assisted by Mountjoy Irish Stout from the late lamented Stone Angel Brewing, formerly in Winnipeg. It is a traditional dark, roasty, dry stout with notes of coffee and chocolate, very much in the Irish style and very much the style of beer that I prefer. And tonight's kit is this one. It is number 26855 from the Universal Solder Collection. Let's see what we got. Does it say on the board? Ah, yes, it does. It is a burglar alarm with time delay. Cool. So we got a couple of chips, couple of LEDs, 5-volt input, speaker, a couple of jumper wires, a few resistors, capacitors, one transistor. Nice, simple little kit to put together. Excellent for relaxing. What is this other bunch of parts here? We got a couple of chip sockets, power connector, a couple of resistors, a little suitcase jumper, a whole cluster of stuff stuck to an 8-ohm speaker. Yay, magnets. So that handful of parts. We have a capacitor. There's a ceramic capacitor, a couple of LEDs, one red and one green, some header pins, a bunch more resistors, some bits of wire, another capacitor, transistor, 9014 variety, which I think is just basic generic NPN, another suitcase jumper, power plug, and a couple of chips. One of which is a CD4011, which I believe is a NAND gate, and the other one is an NE556, which is basically two 555 timers in a single package. Well, that's a nice little assortment of components. Let's go check the website and see if there's a schematic or build guide or anything. Not that we need a build guide. A schematic might be interesting to see if we can figure out how this thing works. As it said on the board, this is a burglar alarm with time delay. Uses an NE555, and actually it's a 556, which is two 555s, but whatever. Currently, it is on sale for $3.57, which is super cheap for a kit. Regular price is just under $6. So it looks like we're using 4 sections of that 4011 and both halves of the 556, which makes sense. Why would you have a dual section chip if you weren't using both sides of it? Just a quick look at it. Discharge on both sides is between 2 resistors, and trigger at the other side. So these are both oscillators, both operating as astable multivibrators. There's about 3 or 4 different ways that you can run a 555, but in this case, they're just each becoming oscillators. And the output of this one goes to the control input of the other one. So I'm going to guess that these two are running at different frequencies. It's pretty obvious that they are because the resistors and the capacitors in the oscillation section are different values. So my guess is one of them is going to be an audio frequency and the other one's going to be a low frequency that turns it on or off. Or, wait a minute, if we're going into the control voltage here, maybe the first one is changing the frequency of the second one from between 2 different states. Something like that. That's my guess anyway. The output of the first one also goes to control the red LED, so it will be flashing in time with that lower frequency oscillator at 10 microfarads versus 100 nanofarads. Yeah, that'll be the lower frequency one. So that red will be flashing when this oscillator is running, and this one will be also flashing in time with it by the looks of it. And that audio oscillator, that two-tone audio oscillator, is almost identical to this chirp generator that's in the Forrest Mims 555 book. A classic of electronic literature, if ever there was one. This book here, it is available online. Actually, I'll put a link down below to this as well as to the kit. Anyway, according to this, J1 is the alarm input and J2 is basically a panic button. So J1 closed, and that goes to your door switch or whatever. And J2 open, so if you hit that, that becomes a panic button, which brings that input low, Normally it's held high by that pull-up, and presumably with, let's see now, so this one is held low. That's both of those, so the output will be inverted, so that'll be high. So when they're both high, that's low, which is going to the reset of both sides of this, so that's clamping those two oscillators off. So when either of these trigger, either this one closes or this one opens, that will cause that to go high, which will allow these oscillators to operate. Right, okay. Except when this one goes open, then we will have a time delay here, because that will charge that capacitor up. Because when we're in the standby mode, that's held low. So that's held this basically at 0 volts or almost. So that will take a little bit of time to rise up before this one will switch. So there is your enter delay on the alarm. Okay. So the timer is entirely being used as kind of a siren-y oscillator thing, and the time delay when the alarm is triggered happens there. Neat. Nice straightforward circuitry, well, relatively anyway. And again, like most of these kits, it is demonstrating a few different principles of electronics. Anyway, let's just get started. We'll pick some resistors. As usual, I'm going to start with the resistors because they are physically the lowest profile components, so they're not going to get in the way of other stuff. They're also the least likely to get damaged by subsequent soldering activities. So this 3-pack is 10K, which according to the schematic is R4, R6, and R9. As much as I love these universal solder kits, that's the one advantage that a lot of the Chinese kits have, is they have the component values marked right on the silk screen. But because this schematic is available on the website, it's not that big an inconvenience. There's our 6. Where are the other two? Our 4 is that one. And our 9 is right beside it there. People are going to complain that I'm using the wrong tip. I happen to like this shape. I'm used to it. I'm comfortable with it. It's a good idea when you're starting out in this hobby to try a few different shapes of soldering tip until you find one that you prefer, that you're comfortable with. Somebody's probably going to tell you that you're wrong. That's okay. You don't have to like the same thing that other people do. It's a great thing about this hobby. There's a lot of different ways to do it correctly. All right, next pair of resistors are 1K. 1K is R7 and R11 down there in the base of the transistor. There's R11. Where is R7? Here it is up there. Okay. In the past, I have stuffed all of the resistors in and then soldered them all at once, but I have discovered that that causes a bit of an inconvenience because the leads all get in each other's way and, more importantly, get in my way. So I am just going to do a couple at a time here. It takes a little bit longer, but you're not getting in your own way. Right, more resistors. What are you guys? 96K, 97K, probably 100K. Without my finger in there, 98. Those would be the 100Ks, which are R8 and R3. R3 is over here, and R8 is down in that corner. I could be using the component lead bender tool to bend these, but not everybody has one of those, and it's not all that much of an inconvenience just to do it with your fingers. I did it like that for years, and I just got in that habit. The last pair of resistors are 500 ohms. actually 510, which means those two are the series resistors, the current limiting resistors for the two LEDs, which would be R1 and R2 just up here. And there's two more resistors left, and they are each individuals. Just quickly check those guys. 550 ohms, which is within tolerance of being a 560, so that's R10. R10, 560 ohms, goes down there. And the last resistor should be this one that's missing, R5. Let's see if that is what it is. 5K. And yeah, R5 is 5.1K. So what's next in my pile of parts that is not easily damaged and doesn't take up too much space? We got a couple of ceramic capacitors here. C2 is 10 nanofarads and C3 is 100 nanofarads. And there we go, 10 and 100 nanofarads. 10 nanofarads goes in there, and 100 goes over there. So that 10 nanofarads is just for stabilization, and the 100 is the higher frequency timing capacitor. Just have to move the board to get at that one. That's not a big deal. There we go. So now, do we carry on to small components, or do we carry on with less likely to be damaged components? If we do the sockets now, are they going to be in the way? Not really. If we do the electrolytic capacitors, they're also not going to be in the way. Let's do them next. We have 100 microfarad and a 10 microfarad. 100 microfarad is C4, the timing capacitor for this. And the 10 microfarad is C1, which is the timing capacitor for the low frequency oscillator over here. As always with electrolytic capacitors, look for the polarity mark. There's negative on the short lead. There's positive marked on the board, which would be the long lead. Is if you don't, well, in this particular application, that one probably won't cause any damage. In a lot of instances, if you put them in backwards, you can risk sparks and explosions and all sorts of excitement. If that's your desired outcome, then go for it. Otherwise, let's just pay attention to the markings. Next, I think I'm going to put in the chip sockets. They're not going to be getting in our way now that most of the components are in, and they are unlikely to be, as I said before, damaged by ham-fistedness later on in the process. The sockets don't really have a polarity, but they do have a notch indicator, which can be useful later, so we will go with that. You see, it's only at one end, and on the board there's also a notch up there indicating this is the pin 1 end. Also, there's a dot indicating the pin 1 end. So if we keep that all coherent, then that will help us remember to put the chip in the correct orientation, because that does matter. A lot of times I will use something to hold the chip sockets in place when I flip the board over just so it doesn't fall out, but because those pins are so bent, it's not going anywhere. But still, I will do what I usually do, which is solder one corner and put my finger on the other side, give it a bit of a push, remelt that, and just set it down flush with the board. And go to the diagonally opposite corner, tack that down loosely, and again with the finger on the other side, push. Now that socket's flush to the board and not going anywhere, and I can solder up all the pins quickly. And then repeat with the other socket. And I guess I'll put the LEDs in now. There's one red one and one green one. LED 1 is the red one. And with the LEDs, they are also polarized components. There is one leg longer than the other, and also there is a little flat spot on the side of the case. You can just barely see there. That flat spot indicates the negative side, the shorter leg indicates the negative side. And that one goes over here. You almost let me make that mistake. Why didn't you say something? And the holes on this board are drilled tight enough that those legs hold nicely. Now, soldering one leg only of both of them and flipping them to make sure that they're sitting straight and level and even and parallel. If they aren't, adjust them. Since they are, down goes the other leg, and we're done with those guys. I'm going to leave the transistor for last because it does have connections to some of the pins that I'm going to be soldering. So I will move over to doing the header pins on the outputs here and the jumpers and the power input jack. Now that doesn't want to stay there, so I'm just going to throw a blob of blue tack on top of here to hold it in place while I'm soldering it, as I don't want it falling off, and there's enough exposed metal that I don't really want to burn my fingers holding it in place on the other side. Next, we'll throw in the two jumper pin, or the two sets of pins for the jumpers. Just snap them off the set there. I noticed that he gave me more pins than I needed. This is just a standard length that he sent in the kit, and I will be able to add the extras into my collection. As I mentioned earlier, the holes in this board are drilled a little bit small. You can get the components in, they just fit nice and tightly, which isn't really a major inconvenience, and it certainly holds the parts tight when you're soldering them, which is actually kind of nice. Next up, I'll just tin up the pads on the speaker that was included in the kit and put the wires on it, and those can just go in there. The color code really doesn't matter. The only time a color coding and polarity matters for a speaker is when you've got multiple speakers and you want to keep them phase aligned, but that's not going on here, so I'm just going to use the soldering iron to kink those over a little bit and hold them in place. There we go. Just a bit of blue tack there to hold it from getting in trouble. The last component that needs soldering is the transistor. And as you can see, the silk screen tells us which way to put that, so there's no confusion there. Although even with that, I have made that mistake in other kits before because I wasn't paying attention. Yep, that's some of the cleanest soldering I've done in the entire kit. Nice. All that's left to do now is put the two chips in. And we do have to get the pins lined up on this one again because it got bent in shipping. That is fairly common with chips in kits that are just shipped in bags. But it's not that hard to get the pins all straightened out and aligned. This is the 4011, which is U1 on the schematic. Goes in over here. We have a notch at that end of the chip and a dot in the corner indicating pin 1. And if you recall, we have a notch up there on the socket also indicating pin 1. So you just gently squeeze this guy into place. And I'm partially seated, then zoom in to make sure that the pins are all going where they're supposed to, and then send it home. And that only leaves the 556, the musical chip, which is coincidentally labeled as U2 on the board. That's a good name for the chip that's making the sounds, isn't it? I think so. I'll just straighten these pins out. You don't need a fancy tool to do this, just a bit of patience and a pair of needle nose pliers. Although if you have a fancy tool like this one that Larry hand built me way back a few years ago, then you could use that too. Looking closer at this one, it only has the notch, it doesn't have the dot. And that's common. You'll have one or the other or both. Just get used to the variants. It doesn't matter as long as you've got some sort of an indicator of where pin 1 is. And again, just gently ease it into the socket. Keep an eye on it, make sure all the pins are going where they're supposed to, and push it home. I think we have a circuit. Alright, let's get some power on this thing. I've got my power supply set for 5 volts. And I've got it just set nice and low to 100 milliamps current limit, so that if there is something shorted on here, I'm not going to cause too much smoke or fire or anything. So let's see. Right, it's only drawing about 10 milliamps, so that's good. Nothing horrible going on. And as you can see, I've got J1 connected, which means that it's in its standby waiting for something alarming to happen. J2, the panic button is open. If I hit the panic button, you can hear the audible frequency, the higher frequency being toggled by the lower frequency, which is pulling that control line and changing the frequency of it. You can see those 2 LEDs wig-wagging just as we expected. So now, if we pull J1 and simulate an alarm condition, the timer, C4, and that 100K resistor above it is going to start timing and bringing the voltage up until it hits the threshold for the comparator, the NAND gate to act like an inverter. So, doink, and we just wait for a few seconds. About 11 seconds. That first oscillation sounded kind of gross, so I'm assuming that it just wasn't quite sure what level it was at. So I'll just short those 2 pins to stop it, and then we'll monitor the voltage when I let it go. You can see the voltage coming up again until it hits that threshold, which should be, there we go, just about 3 volts. And it keeps charging the capacitor, but it's above the threshold for the input of that NAND gate, so it doesn't matter what it is. What was that threshold? 3.2-ish volts, something like that. Anyway, yeah, that works exactly how we figured it would and how it's described. Nice. It's a really obnoxious noise, as all good alarms should be. Well, that was a fun, straightforward, simple little kit to put together. Does a good demonstration of a few different principles that you can take and use in your own circuits if you choose to. Very nice. I like it. As I mentioned, I will put links to various things down below in the description. And if you've got any questions or comments about that, feel free to toss them into the comment section down below. Thanks for watching. I'll talk to you later.